All right. Um, give answer that question. So we do have another pre-quiz. I'm working on that currently, so it's gonna be delayed on the posting, but another pre-quiz due tomorrow. Another pre-quiz due tomorrow. Go ahead and put your cell phones away. That'd be, legal and appreciated and polite and beneficial for your learning. Have a conversation. Correct answer is the slower it goes, the larger the index of refraction. So this is the speed of light in a vacuum. This is the speed of light in a material. Okay. Thumbs up when you have a guess. Tell your neighbor. Correct answer is A. You can't go faster than the speed of light in a vacuum. C over C. Okay. So the thing that makes light slow down, so light is a wave. The only thing you can do to change the speed of a wave is to change the medium, the material through which it travels. Well, that's what we're talking about. Okay. Um, so here, just kind of show you. Okay, we'll do it for this half, then we'll do it for that half. Okay, so yeah, it's going from air to water, how it bends. Okay. So it's bending. Can of fog. Okay, good with that? So it is bending because it's changing its speed. Okay. What makes it change its speed? The actual stuff um, is So when light goes through a vacuum through space, it's just electromagnetic waves self-perpetuating itself. But when it goes through a material, those electromagnetic waves cause electrons to jump up to a higher orbital state, and when they fall back down, they emit a photon. And then that photon hits another one on another atom and makes it go up. And so that process, kind of like a chain reaction, that delays light. And it's like, ugh, it goes slower through a material because of that interaction. Okay. Now, why does changing a speed change the direction? I mean, when you're driving, it isn't like put on your brakes like, and then when you speed up, it's like that. Like changing speed doesn't constitute changing direction. So why of all of a sudden that's the reason we're like, oh, it changes direction because it changes its speed. Here's the okay. So light's a wave. Okay, this refraction is a consequence of it being a wave. Could you envision a drone shot footage of a beach? Okay, and waves crashing on the beach. Usually the waves are kind of like staggered. It's like, and it kind of goes like a wave, you know, like it's not like, it's usually the waves are going at an angle relative to the beach. Everybody good with that? Okay. So what we've got is lights going in. Show me normal line with your arm. Where's the normal line? Where's the normal line? Always perpendicular to the surface. That's the normal line. Good with that? Okay. And it's going to change mediums. Okay. My analogy is it's like a wheelchair. Okay. So you're in a wheelchair. In the air, you're like rolling on the sidewalk. And then this is the grass. You travel slower in the grass. So let's say as you go, you're rolling in a wheelchair. This wheel goes off the sidewalk first into the grass, causing that wheel to do what? This wheel slows down. This wheel keeps going the same speed because you haven't adjusted yet. And so what happens because of that? It turns. Kind of like how waves crash on the beach. Good with that? Okay. That's why it turns. That's why it refracts. Okay. Thumbs up when you have a guess. Two different questions in the same question. Based on your reading quiz, tell your neighbor what you think.
Because that would mean that the first material would be faster than the second.
Correct answer is A. Okay, it's going slower. So the slower it goes, the greater your index of refraction. Okay, the slower it goes, the bigger this is. Okay, and as you go from slow to fast, you're going to bend away from the normal line. Okay, so yeah. Tell your neighbor. Okay, correct answer is A. You're going wheelchair. This is no refraction. It's going to, here's your normal line. It's going to bend. This wheel is going to slow down first. It's going to bend towards the normal line. Here's B. It's bending towards the normal line. Okay. Tell your neighbor.
I'll give like 70% confidence on my answer.
Correct answer is? Correct answer. Okay, so when we are measuring light angles, when we are measuring optics stuff, we always, always, always measure from the normal line. Okay, correct answer is A. Always from the normal line. Good? Tell your neighbor. Correct answer is going from water into air, you're going to bend away from the normal line. Okay? Here's no refraction, we're bending away from that. Okay? You have your wheelchair, you're in the grass already. And then you go onto the sidewalk. This wheel speeds up first until they're both on the sidewalk. Good with that? Okay. So oh, so lasers there. There's that. Okay. All right. So going from water into air, you see how it bends away from the normal line? Okay, now, full disclosure, there's lots going on here. At every interaction, there's going to be a reflection and a refraction. Okay, right here, this is causing a reflection here and a refraction here. See that? And then at this interaction between water and air, some of it's being reflected back in. You can see that, right? Okay. And some of it's getting out. That's what this is the one that I care about right now, is that one here, how it's bending away from the normal line. Okay. Seeing that? Good there? Good.
So what is that over there?
That guy is from it bounces around quite a few times. So it's bouncing. Where is that one coming from? Right there. It's from here. It's refracting out. Oh, no, that's not right. Yeah, it is. Yes. So it's hitting the bottom of the tank. I'll make it go away if I hit that right there. Made that go away. When it goes, it's reflecting, goes to the bottom of the tank, bounces off the bottom of the tank, hits the side here. Some of that's getting out. Okay, good with that? All right, so, ooh, we're really missing my pocket right here. It's killing me. All right. So here, a ray of light goes from water into glass at an angle of 28 degrees. What's the angle of refraction? Before I do the math, I want you to guess, estimate, predict, is that going to be more or less than 28 degrees? We're going from water, index of refraction 1.33, into glass, index of refraction 1.52. I guess it is going to bend away or towards the normal line. That's okay. Somehow that needs to be in your schema of how to figure something out with independent of the math. Like you can do the math, we're about to. I guess that's a worst case scenario. Like, I don't know. I guess I'm going to math it. Okay. But you need some kind of factoid to start with. Here are my factoids. I'm real visual. And so I know I have a snapshot in my brain of the laser going from the air to the water bends towards the normal line. That's a starting point for me. Another starting point for me is thinking about the wheelchair analogy. I can visualize that. I can figure stuff out. So from that, I'm able to build my conclusions based off of that. Does that make sense? Like you need something, some factoid, some memorized thing to start with to be able to like build your case. Okay. So what do you say? Is it going to bend away or towards the normal line? Okay. So if it bends towards the normal line, theta 2 is going to be less than 28. If it's going to bend away from the normal line, it's going to be greater than 28. Okay, we're going to find out. So what it starts with is N1, what it goes into is N2. So we're using Snell's law. Make sure you're in degree mode when doing this. So you have 1.33 sine of 28 is equal to 1.52 sine of theta 2. That's our angle of refraction, what we're solving for. When we do this, we find that is, I need to do it again. That is 1.33 sine of 28.6. 0.6, 1.52 sine theta divided by 1.52, 0.41. So theta 2 is 24 degrees. Were you right? It bent which way? Towards or away from the normal line? Towards the normal line. Theta 2 is smaller. Good? Okay. Tell your neighbor. Correct answer is? Correct answer is A. Got a couple different reasons for you. Number one, what is the angle of incidence? Theta 1. Is it 90 or is it 0? You always measure from the normal line. So we're going along the normal line. So 0 degrees. Sine of 0 is 0. So 0 degrees. That's the math reason. Okay. As we go from air into water, we're bending away from or towards the normal line. Air into water. Towards the normal line. You can't get any nearer the normal line than on the normal line. Okay. Next reason, you're in your wheelchair going from the sidewalk into the grass, but both wheels are going from the sidewalk into the grass simultaneously. Boom. You slow down, but that doesn't change direction. You good with that? Okay. And the last is no refraction. Straight in. Okay. Woo! That was getting a little crazy. All right. Have a conversation. These are wet. I know. It's just water. Correct answer is C. The bigger the contrast of your index of refraction, the greater the change in speed and the greater your change in direction. Okay? So this is like we're going onto the sidewalk, but this is coming from grass. This is coming from like mud. This is coming from sand. Have you ever tried to ride your bike in sand? Doesn't go well. Okay? So going from like to the sidewalk, like whoa, like crazy change in direction because there's a crazy change in speed. Good. Okay. Here's what I want. Everybody has a cup. I want you to partner up. But what I want you to do, one person is going to fill their cup up with water. Be careful when you open the spigots. It's highly pressurized. Okay. Second person, go to a lab table or a desk. Gentlemen, control yourselves. Everybody has a dot in the bottom of their cup. Okay? I want you, the person with the empty cup, I want you to rotate the cup away. Sorry, the dot is on the far side. And then I want you to back up until that dot just disappears below the rim of the cup. Okay? The other person with the cup of water pours their cup into your empty cup. And watch. And then flip rolls. Go.
I think
Okay, once you're done, empty the cups. Bring them on back. That's fine. We'll just, yep. Two different sizes. Okay. In order for you to see things, light needs to go from the object into your eye. Your eye is the catcher, the receiver of light, not the emitter. Okay, it's not the source of light, it is the receiver, the catcher. So, In order for you to see the dot, light's coming off of this dot in all directions. But the reason why you don't see the dot is because the ray of light that would have hit your eye gets blocked by the rim of the cup. Good with that? But when you fill it with water, you could see it. Why? Yep. The light, man, the light, that was a horribly unlevel. The light, when light goes from water into air, which way is it bending? Away or towards the normal line? Away. So there's our normal line, and it's going to bend. This ray of light is going to be bent away from the normal line into your eyes. Good with that? Now, when we see things, we expect them to be where we see them. We don't really take into account that light can bend. It's just weird for us. Like when we see this cup, I'm like, there it is. It's not like, oh, there, I'm going to grab it over here because it's not like okay? So we think we see the dot right here. Oh my goodness, that is a horrible. Okay, we think we see the dot right there. Straight line path. Okay? So we think light goes in a straight path, and the apparent depth we think the dot's right there. Good with that? Okay. Now, to calculate the apparent depth, we will be given this angle, this would be theta 1, and this angle that we, sorry, someone last hour is like, can you erase all the lines that aren't important? There we go. Clean that up all right. Good at that. Okay, so we have theta 1, theta 2, because your eye is the catcher, the emitter of light. Light's coming off the object into your eye. Okay. Now, we assume there's no bending. Okay. So, theta 2, so we have this triangle. And now we have this triangle. This is your apparent, like this is your depth apparent. Does that make sense? And this is your actual depth of that triangle. Okay. This angle here, well, this angle is congruent with theta 2. Get with that? Can you roll with that? Okay. All right. Give that one a shot. Thumbs up when you have a guess. Tell your neighbor. Correct answer is A. Higher, we assume the light's coming off of the fish, bending away from the normal line into your eye. We assume we see the fish right there. Okay? So, tell your neighbor. This is where we think we see the fish. The actual fish is right here. You guys read the hatchet? Good book. Survives because of that fact. They learned in science. I love it. Good? So we're always concerned about, what do I see? But, no one ever asks, what does the fish see? I mean, what the fish is pointing to, the fish has feelings. Have a conversation. Correct answer is. All right, so remember the eye is the catcher, the receiver of light. Okay, so light's coming from the spear and bends towards the normal line into the fish's eye. That was didn't even get the fish. Okay, so the fish assumes straight line path. Hey, okay, it makes sense what the light's going from and then into. Okay, this is the same path. Oh, where did that go? This is the same path of what we had here from the fish's, sorry, from our point of view. Light's going from the fish into your eyes, but that eye sees a path in a straight line path. See the difference there? Okay. All right, so some examples you see around. So a frosty mug of root beer. You notice how thick those mugs are? But it looks like it's like full of root beer. But that's because of refraction. Really, you're getting gypped. There's not much root beer there. Crazy. So this is why you get swirls, waves. Okay. So this polar bear and these people obviously are not decapitated. Okay. If you notice, you can see it here and definitely here. You're not looking straight on these aquarium windows or swimming pool windows. you're off at an angle, like the camera's off at an angle. Okay, so the guy's body is obviously here. So as light's going out of the water into the air, it's bending away from the normal line into our eyes. So we think we see the guy's body there. Same, the window's just angled the other way for this one. Good at that? And those are just some, I mean, you can do this cup of water. So, got a pre-quiz due tomorrow. I'm still working on making it.